Hello everyone, let's talk about this question. This is part of Codeforces Round 1076 Division 3 and it's called reverse a permutation. We are given a permutation of length n in an array form with n distinct elements from 1 to n. So if n was 5, it would look something like this. It could be any other setup as well, but it can also be 2, 3, 1, 5, 4, all distinct, all going from 1 to 5. None of them will be repeating. We are told that we can perform the following operation exactly once, and the operation is to choose a left and right index and reverse that segment in the permutation. The reason we will reverse that segment is because our output has to be the lexicographically maximum permutation that can be obtained by performing the operation. A lexicographic permutation is greater than another one when the first value or the ith value of the first one is greater than the ith value of the second one. Let me try to explain that. Let's take our example that we had here, 2, 3, 1, 5, 4. Lexicographically, I would say a greater value in this case would look something like 3, 2, 1, 5, 4. This is one of the possibilities, but this can also look something like that: 5, 4, 3, 2, 1. As you can see, the examples I wrote down here have their first value greater than the first value of the example that we were given. But there is another situation. Let's say our example looked something like this. We had 3, 1, 2. Now this can also be made into a lexicographically greater value. It just won't be from the first element. You can see that the first element is 3. We cannot have anything greater than 3, but to make it more optimal or greater, we can change the positions of 1 and 2 here and make it look something like this. This would also be a lexicographically greater array. This is what we have to do. We have to figure out 2 indexes. Let's say we found out 2 indexes here, which were index 1 and index 2, because index 0 is 3, and then we switch index 1 and 2, and when we switch them we get 3, 2 and 1, which is lexicographically the maximum we can get with the one operation. That is the idea behind this question. Now let's look at our inputs. We're said that we're given several test cases t. The first line of each test case is the number n, which is the size of the array, and then in the second line of each test case we have all of the distinct values that make up n. As mentioned earlier, our output should be lexicographically maximum permutation that can be obtained with one operation. Now let's see how we could do this, and for that let's take this example. We're given this number. We know n is 4 and all of the values for n equal 4 are given here. As we can see directly, the maximum value out of these 4 values is 4, but that 4 value is not at the position that it should be, which is the first position. So what we can do here is essentially reverse the whole array and make it look something like 4, 1, 2, 3. Here we have taken our left value to be 3 and our right value to be 4 and reversed that array. That is all we're doing in this question. The way we can do this in code, let's think about it here. Code idea. Our first job has to be to find the maximum value in a sub array. So find max value in a sub array. We do this because to make it lexicographically the greatest or maximum, we need to find that maximum value. Once we have done that, we track of the L and our positions. We keep track of the L and R position because this will help us reverse the array if needed. While we're doing that, we will check if our array, which we can call A, or rather let's call it array, at I is not equal to our maximum value. We do this because if we find our array at I to be the max value, then we can simply move ahead. For example, in this example that we looked at earlier, 3, 1 and 2, when we're going through the subarray, we'll see that 3 is the maximum value in the subarray. We'll keep track of our L and R values, and we'll see if array at the first position for right now is equal to the max value or not. If it's not, we would have to reverse that string, but if it is, we simply have to move on to the next element and perform all of these operations again with a shorter substring right now. So when we find that 3 is the maximum value and then we don't have to change anything, the next subarray that we will be looking at is 2 and, or rather 1 and 2, and then we will perform the max value subarray thing again. We'll find that 2 is the maximum value in the subarray. Our L and R will be keeping track of, and lastly we'll check if our first value in the array here, array at I, is the maximum value or not. As we can see here, it is not the maximum value. Since it is not the maximum value, we'll assign the index of the first element to L, and R will be the position of our maximum element. As I mentioned above, let me write it here as well. Our L value is the left value. Our R value would normally be our max values position. We're keeping track of these just to perform the reverse operation on them later. This is the idea behind the code. We will implement this right now. I will start off with my template. We will long test case, input that. While test case is positive, we will input long n, which is the size of our array. We will initialize a vector long, let's call it a n, and then we will input the values in that array like that. Once we've inputted all of the values, we will assign our L value to be -1 and our right value to be -1 as well, because we haven't found a proper subarray to reverse. Once we've done that, we'll start looking for our maximum value. Say long, let's call this max value, max val, which will be equal to 0, and our long max values position, which will also be equal to 0 when we're starting out. After this point, we will initialize another variable j, which will be equal to I plus 1, and we will check if the value at a j is greater than our max val here. If that is the case, we will assign the value of max or max val to the value that we found at a of j, and our position to be, or maximum position to be j. Once we've done that, we have to check if the value at a of I is not equal to the max value. If that is the case, we will assign the left value to be I that we're checking for, and our R value will be our max position, and then we'll break off of this loop. After breaking off this loop, and just to clarify, we're breaking off here because we're only allowed to do one operation. So once we've found that this condition is satisfied, we can simply break off. After this, we will check if the value of L is not equal to -1. That would essentially tell us if we have found subarray to reverse. If this condition is satisfied, we have found our subarray to reverse, and then we will simply reverse a dot begin plus the value of L that we found, comma a dot begin plus the value of R that we found, and +1, because in reverse the left side is inclusive and the right side is not, so we have to add +1 there. Once we have reversed this, all we have to do is to output our array, and that is it. So for I less than n, we will output a of I, but if I is less than n-1, you will see out a space as well. After that, we are simply going to output \n, and that is it. One thing we have to do is to include our vector and algorithm because we use them. And now let's check if this works. When I tried to compile this, it did not work, and I realized I made an error here, so apologies for that. In this case, our maximum value would be a of I. Maximum value's position would be just I and not 0 and 0. Now let's try to run this and see if it works. We did get a correct answer here, so this code works. Let me know if you can find a better way to solve this. This looks incredibly odd to me, so I think there is a better way to find an answer to this. This is an O of n squared solution, so maybe there's a O of n solution, but that is it for this video. Let me know your thoughts in the comments, and thank you so much for watching.